remember what I've told you, that my philosophy has changed from you have homework to do to you have to practice. And again, if you're not doing well, my question is not have you been doing your homework? It's going to be how much have you been practicing, and show me your practice work. We were looking yesterday at factoring things that weren't as simple as a times x squared plus b times x plus c, but were more complicated, like a times this thing squared plus b times this thing plus c, where this thing can be anything. It could be x squared itself, it could be p cubed, it could be 2x minus 5. And you have to be able to wrap your head around how to factor things like number 1. Remember, we're not solving any equations here. You're only talking about factoring, which is part of this unit. On your exam, you could be asked to factor these things. You could be asked to factor those things. Some of you might want to give 3 a shot, but it's maybe a little bit beyond us. Something like that. Things like this. These are all expressions you should know how to factor. Go ahead, Ariana. 4? So the first thing that you want to ask yourself is there a common denominator? Sorry, let me finish writing this down first. Is there a common denominator among the coefficients? And the answer is no. Like, there's no number that 16, 65, and 4 are all divisible by other than 1. So we're stuck with this. We can't make the numbers simpler. The reason why what I'm about to show you is going to work is because the degree or exponent, if you like, of the first term is even. That's the first observation to make. And the reason why that's important is because if it's even, you can split up and put a to the 4 and a to the 4. You're splitting a to the 8 kind of down the middle, because a to the 8 is a times 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 a, so you can put 4 of those a's in each term. The reason why it's going to work as well is because the exponent on the variable in the middle term is half of that 8. And that's going to be important because when you multiply your inner and your outer, they are going to be a to the 4 terms, so it's all going to work out. So now we're stuck with the number aspect of this. 16, I would automatically assume 4 and 4. Okay? This is a tough one, but I can tell by looking at this question that if it's factorable, and I want to just run this through my head to make sure, if it's factorable, it turns out it's got to be 16 and 1. It's got to be 16 and 1, and here's what went through my head. If it's 4 and 4, which I've taught you is kind of what you should try, right? The numbers closer to each other. Then you are stuck with this 4 being factored into the remaining 2 pieces. And the 4, there's no question about it. It must be 2 and 2. Actually, I did this yesterday. It might not be 16 and 1. I did the same thing yesterday. So let's try 4 and 4 first and forget everything that I just said. Are you with me, Ariana? Okay. So it doesn't have to be 16 and 1. I think it might be, but we'll find out. No, I'm going to go back on it. If you choose 4 and 4, now I'm back to my original thought, that can't work because the 4 here has to be 1 and 4, right? Or 2 and 2. And if it's 1 and 4, then you are going to have to put a 4 in one of these 2, thereby creating a common factor of 4, but this is my eyeball looking at the beginning, there is no common factor of 4. So it can't be 4 and 4. And so I was right in my initial thought. It can't be 4 and 4, and it also can't be 8 and 2. Because these are both even numbers. And if it's 4 and 1, I'm going to have to put a 4 in one of these. I never got around to saying it, but it could be 2 and 2, right? But if it's 2 and 2, I can't put a 2 here and here either because I create common factors. It's got to be 16 and 1. Because no matter what I do, let me erase this now. No matter what I do, I am going to have to put an even number for the 4 in one of these brackets. How many of you see then by that logic, and not everybody will get this, that it cannot be 2 and 2 for the 4? Because if it's got to be 16 and 1, then it can't be 2 and 2 because then I would be forced to put a 2, which is an even number, with the 16a to the 4, which is even. And then I would have a common factor of 2. And by the way, then it has to be 4 and 1, and I can't put the 4 with the 16. It must be that. So now we're going to do our foiling and check this out. These would both have to be negative, by the way, to make it work. My outer is 64a to the 4. My inner is an a to the 4. Yeah, it's working, isn't it? Okay. Now, 16, well, we'll start with a to the 4 minus 4. That's a difference of squares. It can factor into a squared plus 2, a squared minus 2. The 16, a to the 4 minus 1, is also a difference of squares. 4a squared plus 1, 4a squared minus 1. This is a difference of squares. So we have the 4a squared plus 1. Then we're going to have 2a plus 1, 2a minus 1, a squared plus 2, a squared minus 2. Does that make sense? I'm not asking if it's easy, but you followed it? You can never factor a sum of squares, like 4a squared plus 1. It won't work. I'm just going to throw this out here for the top end of this class. Is a squared minus 2 a difference of squares? No? Let me ask you this. Is it a difference? Is it a difference? Yeah. Is a squared a perfect square? Is 2 a perfect square? Isn't it the perfect square of the square root of 2? There will come a time, if you take calculus with me, where we might decide to say the following. This is an added thing to this. This is not what we would do at this level, but I'm saying if you FOIL this out, you're going to get a squared minus 2. Because root 2 times root 2 is 2. So it turns out as long as there's a difference, you could always factor something as a difference of squares technically. Anyway, is that okay? Any other questions anybody would like me to go over? Okay. So now we are going to look at the next lesson, 20.4.3, solving quadratic equations by completing the square. I bet you were disappointed when we finished working with completing the square because you probably thought, oh, we'll never get to complete the square again. But we do. Okay? So we are looking now at completing a square, not to determine where the vertex of a function is. We're completing a square to solve an equation. So we have a number of warm-up tasks here. A couple of them, this isn't really warming up to completing the square, but let's solve this equation A. Knowing what we know about quadratic equations, we would zero the equation, which would mean we would take 2x squared and subtract 37 from both sides, which I believe, if I have 5 minus 37, gives me negative 32. Am I right? Nobody, eh? Is that right? Okay, there we go. Okay. We have a common factor of 2. We can factor that out and have left x squared minus 16. Speaking of differences of squares, we can factor that into x plus 4, x minus 4. This is really just a warm-up of old material. And this is equal to 0. Don't forget your equals 0. That means that x equals negative 4 and x equals positive 4, which we could write as x equals plus or minus 4. Right? All right. Let's zero this equation. I'm going to move the 4t squared to the other side where it becomes positive. I'm going to subtract 11 from both sides to get minus 27, and this is equal to 0. Can you verify those numbers for me? Okay. Is that a difference of squares? No. Don't take what I just showed you about the root 2 thing and do it this way. We're back in Math 20-1 land. This is not a difference of squares. So you can't factor it. So how do you solve it? Well, I talked about this yesterday. If there's no linear term, you can always solve it by just rearranging for the variable. I can add 27 to both sides. I can divide both sides by 4. And then I take the square root. But I have to remember that when I take the square root, I write plus or minus the square root of 27 over 4. And, you know, I did something here that's just, my brain gets into autopilot. When you take the square root of a fraction, you learned in Math 10C, you can square root the numerator and you can square root the denominator. So the square root of 27 quarters is the square root of 27 over the square root of 4. Now from here on in, finally, you are expected to express all radicals in simplest form. First of all, the square root of 4 is 2, right? I hope. Well, you guys are just done today, aren't you? You just want to go home. I get it. But you're expected to take root 27 and simplify it by writing it as a product of 2 other roots, where one of those other roots is the root of a perfect square. This is grade 10 math. And 27 is divisible by 9. 9 goes in 3 times. Why am I picking on the 9 and the 3? Because 9 is a perfect square. And the square root of 9 is 3. And then we're left with the root 3. So I don't know if everybody remembers this, but Ariana had asked a question a couple days ago about, you know, if something's not factorable, does that mean there's solutions? And I said, well, I don't know how it was worded, but I said, if it's not factorable, there may or may not be solutions. This thing was not factorable, but there are solutions. What I told Ariana and everybody was that if it is not factorable, but there are solutions, 3 times the square root of 3 over 2, and negative 3 times the square root of 3 over 2, that those solutions are not rational numbers. You can find them on your calculator as x-intercepts, but if you go to convert them to a fraction, your calculator shrugs at you and says, no, I can't do it, because it's impossible to write them as fractions. They are They are irrational numbers because they contain the square root of a non-perfect square. Let's keep that in mind as we work through the rest of this lesson. The next warm-up, solve this quadratic equation by factoring. This should be a piece of cake, meaning easy to do. Because the quadratic term has a coefficient of 1, we don't need to use trial and error. You just identify two numbers that multiply to give negative 12 and add to give 4. I am guessing they are 6 and negative 2. Well, I'm not guessing. They're 6 and negative 2. Which means you go through this whole rigmarole of x plus 6 equals 0, which we'll solve in a second, and x minus 2 equals 0, which I hope everybody is just tired of doing. Because you really ought to be able to look here and tell me these answers. Right? You shouldn't need to write down that intermediate step. Can we solve, and that's not the equation. You have a 10 in yours, don't you? I like to copy and paste stuff. What just happened there? I like to copy and paste stuff, and sometimes I copy and paste it and then forget to edit it. Is that correct now? Okay. So can we solve this by factoring? Well, one of the things you could do is simply say to yourself, are there any two numbers? Are there any two numbers that multiply to give negative 10, and those same two numbers add to give 4? And the answer is no. When you go through an exhaustive list of all the factors of negative 10, you will never encounter a pair of numbers that multiplies to give 4. So it's not factorable. This doesn't work. Another way you could do this, and I want everybody to do this, please, is to calculate that b squared minus 4ac. It's a very special number. Whatever b squared minus 4ac is, it tells you if something's factorable. It tells you if there are even solutions. We will learn the deep details of that later on in the unit. But to start with, when we calculate b squared minus 4ac, you're going to get 4 squared minus 4 times a, which is 1, times c, which is negative 10, and you get what I believe to be 56. And 56 is not a perfect square, so it's not factorable. I don't want to bog you down with a bunch of stuff to memorize, because we will learn why this is the case later. However, if b squared minus 4ac is a number greater than 0, regardless of whether it's a perfect square or not, there are going to be two different solutions to the equation. Okay? I'll tell you right now, and some of you will start making connections to what I'm saying and the stuff we're learning, those two solutions will be irrational numbers if this is not a perfect square. They will be fractional numbers if it is a perfect square. And I'm going a little bit off track here, but if it is a perfect square, it's factorable, so you're going to have fractions as answers. So this is not factorable. Are there solutions? Well, I already told you there are, but let's find the solutions on our graphing calculator. We are going to graph x squared minus 4x minus 10, zoom 6. There's that thing, Lynette. So you just hit enter again. And we can easily find those numbers. Okay. I would like you to take a minute, please, and find those two numbers, those two x-intercepts, while I do something up here. do you in fact get those numbers? Okay. You'll notice I got them in a different way, but we'll learn about that next week. These are the two x-intercepts. Okay. So those are their approximate values. And again, I just want to highlight the point that because it's not factorable, these numbers are irrational. These decimals go on forever and never repeat. You cannot express it as a fraction. By the way, you don't need to write down 1.74, 1657, 387. You can write 1.74. Yep.
I didn't get that.
Who didn't get those? Oh, okay. Let me double check. Well, let me do it with my, I thought I was being smart and doing it a different way, but, oh no, it's like negative 2 point something, eh? They're what?
Negatives are only in the opposite one. I think you typed in, no, the first one's still 1.7 and it's actually 1.
Ah, this is positive. So Danielle, if I actually put in positive,
Oh wait, turn it right. Oh yeah, we all just put in what you put in.
I know what happened there, and that's my fault. I typed in the incorrect function. I typed x squared minus 4x minus 10. A whole bunch of you just typed that in as well because you're supposed to do what I'm doing. And when you found the x-intercepts, you didn't get the answers that I got. I got the right answers despite putting the function in incorrectly because I did it a different way. I didn't use my graph. So that's why I was kind of wondering, we were kind of split that most of you were saying you were getting the right numbers, but a whole bunch of you were saying you weren't. Did that clear it up over here as well? Okay. So are we okay that the two answers are, when you actually follow my lead now and put in the right function, those two numbers? Okay. So when you did it with the negative 4, which was what I put, you had the opposite, right? Yeah. Okay. All right. Well, look, if a quadratic equation contains ax squared plus bx plus c, and that's not factorable, you can still solve it by completing the square. And that's what we're going to do. We're going to do 4 examples and show you how to rearrange an equation for x because you can't factor. Now, next week, I'm going to show you another method for solving a quadratic equation, which trumps everything, which you can use all the time for any quadratic equation. And what I will tell you is, unless you're a very unique student, I don't think after next week you will ever have to complete the square again to solve an equation. You'll complete the square to solve application problems, but solving an equation with completing the square is the least desirable thing you want to do. Not ever, but in terms of choices of solving an equation. So here's how it works. Let's solve this by completing the square. This is the weird thing. We're used to solving, or completing the square rather, by having a y over here, right? There is no y over here. What it is 0. And we're not going to make it a y. And whether you put the 0 on the left side or the right side doesn't matter. We take the negative 10 and move it over out of the way. And because the coefficient of the x squared is 1, I'm ready to add my number to complete the square. I don't have to factor anything out. And what I do is I look at b, which is 4. I take 4 and divide it by 2 to get 2, and then I square it to get 4. So what this is now, let me put a different color there. What this is a perfect square trinomial. it is going to become x plus 2 squared. It's going to become, if it was y equals, it's going to become x minus p squared. It's not y equals. We're not thinking of vertex here. It's got nothing to do with a graph. Now we have to subtract 4. So whatever we did in here, we have to undo out here. And that means, and don't forget this whole thing, the way I wrote this, it might be a little confusing. So I want to make sure the confusion is as small as possible. This entire thing is this, right? So then we have minus 14. And this is equal to 0. And you can rearrange this for x. X is inside that set of brackets. Before we remove the square by square rooting, we'd better get rid of that negative 14. So I'm going to add 14 to both sides. And now I have 14 equals x plus 2 quantity squared. So how do I get rid of the squared? I take the square root of both sides. Now, I've done something wrong, this time intentionally. What is it that I intentionally didn't do here that I need to do to get the answer properly? You mean x plus 2 times x plus 2? If we do that, we're digging ourselves into a hole we can't get out of. If we do that, what's going to happen is you're going to go back up to the x squared plus 4x plus 2. Kendra has it, I think.
You should have put the square in there and then subtracted 4. Like you should have squared all the things, then subtracted 4, then did the square root of 10.
No, I don't. I'm not quite sure I get what you're saying. Okay, first of all, so no, because x plus 2 squared is never x squared plus 4, ever. X plus 2 squared is x plus 2 times x plus 2, right? And that's okay. From time to time we think that way. So, and by the way, again, you and Brody are kind of along the same track. If you square this first, then all you will be doing is just going back up to here. Let's just leave it now, and I'm going to come back. To correct this, we're just going to make a small adjustment to it. Let's continue. Let's solve for x. So I would have to subtract 2 from both sides and get, I'm going to write negative 2 plus the root of 14. That's how we normally write a mixture of numbers and roots. Okay, so we get x equals negative 2 plus the square root of 14. I would like you to calculate negative 2 plus the square root of 14. But we didn't get negative 5.74. We got the 1.7416 whatever. Why didn't we get this? This is the mistake. Because you're supposed to get 2 answers. Do you know?
Put the
Plus or minus root. And this is going to become more and more important as we go deeper into high school math. That when you introduce a square root, you have to say plus or minus. So what happens is this equation is positive root 14 equals x plus 2, and it's negative of root 14. Now that just means whatever the square root of 14 is, you multiply by negative 1 equals x plus 2. And when you solve this equation, you subtract 2 and you get negative 2 plus the square root of 14 equals x. When you solve the second equation, you get negative 2 minus the square root of 14 equals x. And I hope you understand what you're going to get if you figure out what negative 2 minus the square root of 14 is. You're going to get that negative 5.74. You can confirm that? While you confirm that, I'm just curious what this little thing is. So those are our two solutions, and they are exact values. So the solutions to this equation, algebraically, not with our graphing calculator, are these two numbers, and there is nothing wrong with you writing from this line right here, writing x equals negative 2 plus or minus root 14. You don't have to write negative 2 plus root 14 and negative 2 minus root 14. You can write negative 2 plus or minus. So that's what we're doing today. We're completing the square to solve equations. So example 1. Is it factorable? I think it is. So as a note, we are asked to solve the following. It doesn't say by completing the square, but as a note, even though this is in the completing the square lesson, why would you complete the square when you don't have to? This is my thinking. Is completing the square more complicated than factoring? I think so. Anything that's more complicated runs a higher risk of you making a mistake. Don't make things overly complicated if you don't have to. Two numbers that multiply to give negative 27 and add to give negative 6. Are negative 9 and positive 3, which means the solutions are 9 and negative 3. Child's play. Really simple. Any questions with one? You can decide to write this down or not. I'm going to complete the square and show you that we will get the same answers. And again, you don't have to write this down. If you want to, that's fine, but I'm not going to go really slow. I would have to take and add some number to this to make this a perfect square trinomial. The number would be 9. I want you to think for a second about why I'm adding 9. It's half of 6 squared. That would mean I would have to subtract 9 over here. This would become x minus 3 squared minus 36. I think. 36? Yeah. Equals 0. Let's unwrap this. Let's move the 36 to the other side. Take the square root. And have x minus 3 equals plus or minus root 36, which is 6. Right? The square root of 36 is 6. So you get x minus 3 equals plus or minus root 6. Root 36, which is 6. That means x equals 3 plus or minus 6, which means x equals 3 plus 6, and x equals 3 minus 6. 3 plus 6 is 9, jackpot. 3 minus 6 is negative 3. But a lot more work, right? Yep.
Would this method still work if both of the x-intercepts were positive or both of them were negative?
Yes. Yeah, and hopefully we'll run into one. So far it appears, and I like that question because it gives me something to think about as a teacher. I never thought about my lesson that way, that maybe all of my examples have a positive and a negative answer. I don't want you to think that that has to be the case. It will work no matter what. I'm going to try to remember so when we get to the end of the lesson, we can check that out, if we don't encounter it in the remaining examples. So t squared minus 9t minus 7. Now the algebra is going to get a little more complicated here. We can take the t squared and the 9t and really separate them from the constant term, which is what you need to do visually for completing the square. And I need to take 9 and divide it by 2, which will give me 9 halves, and then I need to square it. So the number I'm going to be adding in here is 81 fourths. By the way, I don't know if you remember, but on your unit exam in the last unit, there was a question that you had all these fractions you had to pick from to fit the person's work. There was 9 quarters, 3 halves, all that. I was really impressed that almost everybody got that right. So you guys can do this. I do need to subtract 81 over 4. This becomes t plus 9 halves, quantity squared. And then we have to figure out what this is. I'm old school, so I'm going to do it by converting to a common denominator. I'm going to have over 4, 28 minus 81. I want to say 33. No, 53. Negative 53. 81 minus 28. Negative 53 on the top. Okay. Negative 53 quarters equals 0. See, now we can rearrange for t. And I don't have a problem with you just tossing this into your calculator today to see that you get negative 53 quarters. That's not the point of today's work. Kendra, you have a question? Don't apologize. It's okay. No, I did 28 minus 81 because it's 7 over 1 and 81 over 4. So I have to multiply the top and the bottom by 4. Oh, you're not confused. I am. It is negative 7. Good catch. So let me reevaluate that. It's 28 and 81, which is 109. Negative 109. You got the same thing, Danielle. Negative 109 quarters. And never be afraid to say, how'd you get that? Because you know me. I will make a mistake. I've long ago given up trying to be perfect because it's not going to happen. So is that good now? Okay. Now what I want to do is rearrange for t. And that involves peeling things off. I've got to get rid of, I have to get rid of this first. After I get rid of that, I need to get rid of the squared. After I get rid of the squared, I can then worry about getting rid of the 9 halves. So I'm getting rid of this, then this, then this. How do I get rid of the negative 109 quarters? I move it to the other side, or I guess mathematically what I'm doing is I'm adding 109 quarters to both sides. I've accomplished the elimination of the blue thing from surrounding t. Now I got to get rid of the green thing surrounding t. That means I take the square root, and I'm going to have plus or minus root 109 over 2. Because the square root of 4 is 2. Right? So it's the square root of 109 over the square root of 4. But the square root of 4 is 2. And then we can finally eliminate the yellow thing and get t equals negative 9 halves plus or minus root 109 halves. We happen to get a common denominator here, so we're lucky. Negative 9 plus or minus root 109 all over 2. Just those of you in class, just forgive me for a minute here. If you're watching this on video and you were wondering about this whole conversation up here, I didn't see, it's not an excuse, but I failed to notice this negative in front of the 7 for some reason. So I had to put it back in here, and that's why we got negative 109 quarters. If I did want you to evaluate back in the classroom what these numbers are, well, I'll ask you to do this. T is negative 9 plus root 109 all over 2, and T is negative 9 minus root 109 all over 2. Can you please calculate those in decimal form? I just want to make sure that you can get the right decimals. So I want to make sure that you know how to use your calculator here. One of the answers is 0.72. And the other answer is negative 9.72. If you were going to enter negative 9 plus root 109 over 2, all over 2, in one shot, then you need to put a set of brackets around the negative 9. You need to do this. That's what you need to enter, then go divided by 2 if you want to do it in one shot. I don't do that. I hit equals, and then I go divided by 2. But make sure you can get the right decimal answer. Okay, good. Last example. 4. There's one more after this. Is this 3? I'm missing 4 then? Okay, so this is number 3. Is that right? I took it upon myself this semester to change all my note packages to improve them, and I haven't really had time to proofread them and change the things up here. This is the correct 3, is that right? Okay, so we are going to have to factor a 3 out of, let me rewrite this first. This step is not really necessary. You're not going to put a number in yet because you have to take that 3 out. Now you're ready to put a number in. Yep.
You can take the 3 out and not take it out of the 2. You don't have to take it out of the constant.
You never take it out of the constant, yeah. If you do, yeah, no, you know what I'm going to say here, Kendra? You never take it out of the constant. And that's maybe why I've said let's move that 2 out of the way, just as a visual reminder that you're not factoring out of the constant. You're only ever factoring out of your variable terms, your quadratic and linear terms. The number we're going to add here is 1. And then we need to figure out what we're going to do over here. Riley, are we going to be adding or subtracting something here? Right, because this is positive, right? What number? I want everybody to figure out what number we're going to subtract. It's not 1. It's 3, right? Because you need to multiply this 3 with this 1. And that means you've added 3, and that means you have to subtract 3. So this this green part where I wrote plus 1, that's equivalent to minus 3 being undone outside of the brackets. Don't lose your equals 0, because if you lose your equals 0, you might get to the next line and go, what was it I was doing? And then you might think you got to describe the function and where the vertex is. That's not what's going on. Now we're going to write 3 times x minus 1 squared plus, I guess, minus 1 equals 0. Look good? I'm not going to do the color thing here. We need to get rid of this first. Normally then we would take the square root, but we have to get rid of something else first before we square root. We have to then get rid of the 3. We'll have removed the 1, and then we're trying to get inside that set of brackets at the x. We've got to bump that 3 out of the way first before we take the square root. So we're going to get rid of this second. Then we can worry about taking the square root. Then we can worry about eliminating that 1. So there's 4 different layers of wrap around this thing. I really believe at this level, given everything we have to do, if you start writing plus 1 and plus 1, it gets more confusing than it needs to be. Move that 1 over. It's that simple. So we get 3 times x minus 1 quantity squared equals 1. How do we get rid of the 3? We divide both sides by 3. How do we get rid of the squared? We square root both sides. To get x minus 1 equals plus or minus the square root of a third, which means x minus 1 equals plus or minus 1 over root 3. Because the square root of 1 is 1. I'm going to show you something, and I want you to tell me if it rings a bell from Math 10. And I always forget whether this is done in Math 10 or not. If you have 1 over root 3, let me go through this explanation, then I'll ask the question. If you have 1 over root 3, in math we don't like radicals in the denominator. So I multiply the top and the bottom of this by the square root of 3, giving me the square root of 3 over 3. Because root 3 times root 3 is 3. Root 3 times root 3 is 9, root 9, and the square root of 9 is 3. So my question is, does this whole process ring a bell? I don't think you do this in 10C anymore. Okay, so we don't have to worry about that. We are going to have to in the coming days, but I'll leave it for now. That means x equals 1 plus or minus 1 over the square root of 3. So ignore all this stuff up here. I would have thought you did it in Math 10, but I guess I'm mistaken. So this is our answer. 1 plus or minus 1 over root 3. That means 1 plus 1 over root 3 and 1 minus 1 over root 3 are your two answers. Finally, you have 2x squared plus 18x plus 9. Let's do something first. Can you calculate what 1 plus 1 over root 3 is? And 1 minus 1 over root 3. Have you got those two numbers? So have you got these two numbers? Are they both positive? There you go. Both positive. Just because we're going plus or minus doesn't mean you have to get a positive and a negative number. And sometimes you'll get two negatives. All right, final one. We're going to take the 2 out, but again, just to make sure, let's move this 9 over here, and don't forget this is equal to 0. I take the 2 out of the variable terms, x squared plus 9x. Oh, more fractions? Man, oh man. I have to take half of 9, which is 9 over 2, and then square it, which gives me 81 over 4. I have to multiply the 2 and the 81 over 4 to find out what effect I had on the equation, and that's 81 halves, which means I need to take away 81 halves. This is still equal to 0. The first part becomes 2, and then we'll have x plus 9 halves, quantity squared, I'm not sure if that's right, but I'm sure you can correct me if it's not. But it is right. So I'm going to have to add 63 halves, divide both sides by 2, take the plus or minus square root, subtract 9 halves. So I'm going to have 2 times x plus 9 over 2, quantity squared equals 63 halves. When I divide 63 halves by 2, it becomes 63 quarters. I'm dividing by 2, so the bottom gets twice as big. This is x plus 9 halves quantity squared. I don't know that I've mentioned this to you this year. Past couple of years are just a blur for me. But I hope you appreciate that when we do this math, we work down from line to line. You don't go equals, 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 left to right. That's a fatal mistake in math. Take the square root. So we get x plus 9 halves equals plus or minus root 63 over 2, because the square root of 4 is 2. This happens a lot where the denominator is a perfect square, which means x equals negative 9 halves plus or minus root 63 halves. Root 63 can be simplified, so I just want to make sure here. You remember earlier, I'm going to go back and show something to you. Remember this bit of business by changing root 27 to 3 root 3? You remember doing that last year, don't you? I hope. Yeah, definitely. So we have to do that with the root 63. Root 63 is root 9, root 7? Is that 9 times 7? Yeah. So that's negative 9 plus or minus 3 root 7 all over 2. That becomes a 3. You know, I hate to break it to you. I hate to, throw this on your lap, but this is a numerical response question. The solutions to this equation are negative a plus or minus b root c over d. What are the values of a, b, c, and d? Well, a is 9. A is 9. 9. B is 3. C is 7. And D is 2. It's a legitimate, we're in the big time now. This isn't grade 8 math anymore. We're high school math students. On page 241, 6 and 7, this is what you're looking at. Solve these by completing the square. What are you going to want to do here? Probably multiply everything by 10 to get rid of decimals, although you don't have to when you're completing the square. I know it's been a long week. I can see it in your eyes, but we still have about 15 minutes here that we can get in some practice.